Hi guys, this is Vicky again, and today we are going to go through the 5 chemical reactions. We are going to talk about the first 3 today, and then I am going to upload another video with the latter 2, okay? Just because it's easier to go through these 3, and then the other 2 are a little bit more lengthy, okay? Cool. So today we are going to talk about the 5 chemical reactions, and they happen to be synthesis, decomposition, and combustion. Let me just write all of the 5 chemical reactions that exist. So the first one is called synthesis, the second one is called decomposition, and then the third is combustion, the next one would be single replacement, and then the next one, and the final one, it's double replacement, okay? So today I am going to talk about the first 3. Okie dokies? Okie dokies. But before we go on and talk about all 3 of these chemical reactions, I want you guys to remember or just remind you guys about the diatomic molecules, okay? So if you guys remember diatomic molecules, they happen to be 7 molecules that are on the periodic table, right? They are 7 atoms on the periodic table that will never ever exist by themselves. They are always going to be paired up. And they happen to be hydrogen, oxygen, chlorine, bromine, iodide, and fluorine, okay? So I memorize it as Hunkelbrief, but you can memorize it any way you want. Hunkleberry Finn or Hunkelbrief, Brinkelhoff, whatever floats your boat. Otherwise, sometimes if you're super visual, you can actually just look at your periodic table and hydrogen is right there, okay? Oxygen, nitrogen, and chlorine, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine are right there, okay? So you can actually create a number 7 on the periodic table if that makes it easier for you, okay? But whatever the case is, I want you to memorize these. This is a must be memorized situation where Hunkelbrief are always going to be found in 2s. Okie dokies? Okie dokies. All right, so with no further ado, let's continue and let's talk about the 3 chemical reactions. So synthesis is the very first one. So synthesis is when we are creating couples, right? I have A and I have B and they're getting together and they become A and B. So atom A, atom B gets together and we create compound AB. Okay, so an example of this would be like sodium and chlorine. They get together and we end up creating NaCl. Easy peasy? Easy peasy. Just remember though, chlorine is part of Hunkelbrief, right? And it just so happens that we have a 2 here. So we have to honor that, and chlorine will never ever be found by itself. So it's Cl2. Do you see? All right, also, okay, see that this is an atom. This is a sodium atom. This is also an atom because it's a diatomic atom or molecule, right? And here we just created a compound. Okay, now that we have this, we can look and we can say, hey, all we have to do is just balance it out, right? And if you want to balance it out, we have 2 chlorines on the reactant side. We only have 1 here, so I'm going to put a 2 there. And by distributive properties, sodium became 2, and now I put a 2 there. And that's it. Super easy, right? Super easy. All right, so that is synthesis. Number 2, it's going to be decomposition. So every time couples get together, unless they're married and they're like committed to each other forever and ever, right? There's a chance that you can break up, right? So that's what decomposition is, okay? So A, B, and chemistry is all about reactions, right? The spark between 2 individuals, whether they're atoms or humans or whatever. So we have A and B, and then we are just breaking them apart, and they break up into A and B, right? Okay, so literally, decomposition is the opposite of synthesis, okay? So Quick question. I have NaCl and they are dividing into Na plus and Cl minus. Would this be a decomposition reaction? No, right? No, this is not a decomposition reaction. Why? This is not a decomposition reaction. Why? It's because they have charges. And look, up here, we have no charges in the reactants. Do you see? Because remember, we said that they were atoms and not ions. So this is not a decomposition reaction, not decomp. So then what the heck is this? This is called ionization, okay, or a physical reaction, or dissolving, okay? Any standardized exam, whether it's the SAT2 or the AP, will always use any one of these terminologies to describe this ionization, non-decomposition chemical reaction, okay? Actually, not a chemical reaction, physical reaction, okay? Cool. So then how do we decompose? NaCl will decompose into sodium atom, no charge, notice, and chlorine atom. But look, this is a diatomic molecule, so we have to put a 2 right there. And then we go back and we just balance it, just like we did up there. Okay, so does this equation right here look exactly the same as this one, but in opposite directions? Yes, that's all we're looking at. Okay, all right, let's continue to number 3. Number 3 is going to be combustion. Okay, combustion is when you create fire. Okay, you create fire. So any hydrocarbon, okay, reacting with oxygen, you end up creating some type of carbon molecule in water. It just so happens that if you have excess amounts of oxygen, like unlimited amounts of oxygen, you will end up creating carbon dioxide and water. But if you have a hydrocarbon and you have limited amounts of oxygen, like not enough, right? Because this is the limiting reagent and whatnot, you end up creating carbon monoxide and water. Okay? And when you create carbon dioxide, right? This is why you don't do campfires indoors, because you want unlimited amounts of oxygen. So you do campfires outside and you create a ton of carbon dioxide. So this is complete combustion. Whereas this right here, imagine if you were to do like barbecue indoors. Would you do it with your windows closed or with your windows open? You would do it with your windows open, because if you did it with your windows closed, you would suffocate, because you would be creating a ton of carbon monoxide because there's not enough oxygen, right? And this is called incomplete combustion. Okay? And that's it. Cool. So I will see you in the next video for the latter 2 chemical reactions, okay? All right. Bye.